All right, welcome back. So we're going to talk about security for machine learning workloads. But before we get started, hit the like button, subscribe, share this with anyone you know taking the AWS Machine Learning Associate exam. So security, identity, and compliance form the foundations of production machine learning systems. AWS provides comprehensive tools for implementing least privilege access, protecting sensitive data, encrypting artifacts, isolating networks, and monitoring activities. So let's go into the principle of least privilege. All right. Principle of least privilege, or PLOP, whatever. It grants users, services, and applications only minimum permissions required for their tasks. In AI and machine learning contexts, this reduces blast radius during security breaches, prevents unauthorized access to training datasets or model artifacts, and limits misuse of expensive SageMaker jobs or destructive operations. All right. So restrictive S3 policies exemplify this approach. A policy allowing only list bucket on specific prefixes and get object on specific file types confines access precisely. Users can list only the data, reports, directories, and read only CSV files from that path, if that's what they choose. IAM Access Analyzer can auto-generate the least privilege policy based on actual usage patterns, recommending minimum necessary permissions. Let's go into data protection techniques. All right, so data masking and anonymization protects personal identifiable information, or PII, in machine learning pipelines. Masking obscures sensitive data, like showing only the last 4 digits of the SSN. Anonymization replaces data with random or irreversible values. Hashing provides one-way encoding. Encryption transforms data into unreadable form, either deterministic or probabilistic. Exclusion offers the best protection. Don't collect or store PII if necessary, right? AWS Glue Data Brew offers point-and-click data obfuscation. Amazon Redshift can support masking policies and column-level security through SQL commands and creating masking policies on specific columns. So SageMaker encryption. Okay, so SageMaker. SageMaker encryption protects data at rest and in transit. At rest, AWS Key Management Service encrypts SageMaker notebooks, model artifacts from training and tuning and inference, batch transformations, and data volumes within SageMaker containers at opt/ml. For training data in S3, use SSE S3, that's the server-side encryption S3, SSE KMS, that's a SSE server-side encryption for KMS, key management system, or client-side encryption. In transit, all SageMaker communications use SSS, SSL, or TLS by default. Optionally, enable intercontainer encryption for distributed training. This may increase training time, but satisfies compliance requirements in regulated environments. So let's go to network isolation. All right. Is that it? Yeah. Okay. Network isolation. Okay. So by default, SageMaker jobs are internet enabled. Running in VPC provides higher security, but requires VPC interface endpoints via private link for S3 access, and NAT gateway if outbound internet is needed. Okay. IAM. So IAM policies define exactly who can start training jobs, create SageMaker notebooks, deploy endpoints, and run hyperparameter tuning. High-cost actions like create training jobs require restrictions, allowing create notebook instance for data scientists or restricting create endpoint to deployment users can work as a way to regulate. Then there's predefined policies that can include AWS SageMaker full access, AWS SageMaker read-only, and AWS SageMaker data scientist. These are common access patterns for IAM that can be used. All right, and you'll see an example here of a JSON policy that can be applied and how you can apply this for the ARMs. All right, here's some example policies I can use. Go forward. All right, so how would you implement this security? One, go to the console, create a KMS key. All right, we've already done this earlier, but when you create a key, you can add this to any job that runs to encrypt it. You do the symmetric, add your labels, add your admin permissions, your usage permissions, and then create it. And then in the SageMaker, let's see. SageMaker AI. Is it SageMaker AI or SageMaker? I can never remember. It's the one with training jobs. That's what we're looking for. Okay, yeah. So it's SageMaker AI, right? So in SageMaker AI, you go down to training jobs. And we showed you this earlier, right? And so that key we created, You can have the IAM role, or that's one permission. We talked about the network isolation right here, or the encryption key, right? So that's another way you can do it, right? So you have the IAM, you have the encryption key, you have the network isolation. And then you can configure the CloudWatch monitoring, or you can look at the SageMaker notebook to look for latency errors, CPU, memory usage, and you can have ground truth for labeling. And you can configure alarms as well for threshold violations. So I hope that helps. So you remember, all right, a couple of things. So for this certification exam, remember a couple of things, right? When questions ask about securing training data, implementing least privilege access, encrypting machine learning artifacts, isolating SageMaker workloads from the internet, understanding AWS security controls, this is how you demonstrate practical knowledge for production level machine learning systems across identity management, data protection, network isolation, and comprehensive monitoring, and how you would answer this on the exam. So thank you for joining. Before you go, hit the like button, subscribe, share this with anyone you know who's taking the AWS Machine Learning Associate exam, and I'll see you in the next one. Thank you. Goodbye.